We've seen the image. We've heard the collision. We know black holes exist. But knowing something exists and knowing what's inside it, those are two completely different things. Scientists have detected nearly 300 black hole mergers, built planet-sized telescopes, launched X-ray satellites, all just to answer one question that has never been answered. Cross that event horizon, and what exactly do you find? Let's find that thing together in this video. Before going inside a black hole, let's understand the basics of how we get this information. Have we ever actually gone inside a black hole, or we have created this data with machines? To be completely honest, no, we have not gone even close. And if we tried, it's a one-way trip to cosmic oblivion. But here is the beautiful part. Humanity didn't let that impossible barrier stop us. Instead, we built tools to peer into the dark. By linking telescopes across the globe, the Event Horizon Telescope captured the first real images of supermassive giants, M87 star and our own Sagittarius A star. We didn't just look either, we listened. Using LIGO, we've detected the ripples in spacetime from hundreds of black hole collisions. And right now, missions like XRISM are using X-ray spectroscopy to watch the violent, glowing dance of matter just outside the abyss. We might be trapped on this tiny rock, but human ingenuity has allowed us to touch the edge of the ultimate unknown. So, what actually happens if you cross that line? Let's step inside, where you will find a cosmic whirlpool of pure fury. Before you even touch a black hole, you are confronted by a screaming, swirling ocean of hydrogen, helium, and iron plasma orbiting at near light speed. Thanks to recent data from the XRISM satellite tracking iron K-alpha lines, we know this isn't just space dust. It is a superheated friction machine, burning millions of degrees hotter than the surface of our sun. If a human traveler were to approach this, the sheer intensity of the radiation would vaporize you instantly. It is a blazing, violent shield guarding the ultimate dark. But say you cross the point of no return. You might expect chaos, debris, and explosions. But the counterintuitive truth, it is completely, eerily quiet. The interior of a black hole is nearly empty. There is no matter here, no fire, no walls, just pure, radically warped space-time. The environment isn't stuff you can touch. It is the geometry of the universe itself folding in on you. Yet, it isn't entirely dead. As we descend deeper, we enter a ghost realm of energy. All around us is a blistering corona of X-rays and gamma rays, cosmic beacons mapped by telescopes like NuSTAR. But beneath that roar lies a whisper, hawking radiation. This is a ghostly quantum trickle of particles slowly leaking from the horizon, operating at just billionths of a degree above absolute zero. The black hole is alive, and it is slowly bleeding energy into the dark. Finally, we reach the absolute bottom of the universe, where we find a difference between the theories of traditional physics and today's science. String theory suggests you wouldn't find a point at all, but a fuzzball, a dense, tangled mess of fundamental cosmic strings. Meanwhile, loop quantum gravity suggests you'd encounter a Planck star, a fiercely compressed, microscopic ball of quantum energy fighting back against the gravity. It is so easy to look at black holes and feel dread, to see them as cosmic monsters. But really, they are monuments of wonder. They challenge everything we think we know about reality, pushing us to think bigger, look closer, and dream deeper. If you want to keep exploring the edges of our universe with us, make sure to hit that subscribe button right now. And if you want to know how we can actually hear these invisible giants crashing into each other in the dark, you'll want to watch our next video on the mind-blowing world of gravitational waves. click right here, and let's keep exploring. See you there.